So for chapter 11, we have the problem and we need to find the overall heat transfer coefficient. Water at an average velocity of 3.5 meter per second flows through a 5 meter long stainless steel tube with a thermal conductivity of 14.2 watts per meter dash times degrees Celsius in a boiler. The inner and outer diameter of the tube are 1 centimeter and 1.4 centimeter respectively. If the convection heat transfer coefficient at the outer surface and inner surface is 8,400 watts per meter squared times degrees Celsius and 23,324 watts per meter squared degrees Celsius respectively, determine the overall heat transfer coefficient, the inner heat transfer coefficient based on the inner surface area of the tube. So, in our lessons, the reporter gave the equation for this matter. So, for resistance, we have the total resistance is equal to the inner resistance plus the wall resistance plus the outer resistance. So, for inner resistance, we have given an equation 1 over the heat convective coefficient times the area, the inner area. For the wall resistance, we have given the Ln, outer diameter over inner diameter, over 2 pi thermal conductivity and length. For the outer resistance, we have given an equation 1 over the outer heat transfer coefficient and the outer area. So what we need to do is just we need to put all the value in our formula. So we have for inner resistance, we have 1 over 23,324 watts per meter cube degrees Celsius times our area, the 3.1416, 0.01 meter, and our length, 5 meter. For the resistance in the wall, we have L of N times our outer diameter, which is 1.4 over 1, our inner diameter, over 2 times 3.1416 times our thermal conductivity, which is given 14.2 watts per meter degrees Celsius, in our length, 5 meter, and our outside resistance, which is 1 over our heat transfer coefficient outside is 8,400 watts meter squared degrees Celsius times the pi times 0.014 meter times the 5 meter. So all in all, we have the total resistance of 0.00157 degrees Celsius over watts. Now, we need to find the inner surface area of the overall heat transfer coefficient. And we have given the formula 1 over the overall heat transfer coefficient inside times the inside area. So we have the inside overall heat transfer coefficient is equal to 1 over the R total, the resistance total, and the inside area. So 1 over our resistance total, which is 0.00157 degrees Celsius per watts, and our area, which is pi times 0.01 times 5, and we have an answer. Our overall heat transfer coefficient inner surface is equal to 4,055 watts meter squared degrees Celsius.